Welcome all. Before starting today's class, let me recap what we have discussed in our previous class. In our previous class, we have discussed about designing a IIR Butterworth filter. In that, we see for the four type of filter, that is high pass, low pass, band pass, and band reject filter, right? So in the previous lab, I mentioned that about the Chebyshev filter designing, IR Chebyshev filter designing, we are going to discuss in the next lab, right? So in this lab we are going to discuss uh, IIR filter designing, IIR Chebyshev filter designing, right? So for that, uh, let me start with a new program file. So yeah, let me rename this. Chebyshev. Okay, so as usual, let me first list out the thing that we are going to discuss in this lab. So let me first then put the thing in this cell, okay, that we are going to discuss today in today's class. So designing of okay, before going into that, let me give some theoretical theoretical point about the Chebyshev filter. Okay, so it is not uh, similar to that of Butterworth filter. Okay, so it is little bit different from the Butterworth filter. Okay, there are two type of Chebyshev filter, type 1 and type 2. Okay, and in type 1, the ripple that are present in the pass band, right? And in the type 2, the ripples are present in the stop band. Okay, so what I will do, let me use the board here, and I will try to draw the figure so that you can able to understand the thing. Okay, so here I am drawing only. Okay, for I'm writing C1. Okay, I'm writing through my laptop keyboard, that's why laptop mouse, that's why it is little bit difficult to draw. So let me do that. Okay, so for Chebyshev 1 and for Chebyshev type 2. Okay, I'm writing C2. Right, so for Chebyshev type 1, the response is like this. Let me draw. The frequency response of the Chebyshev type 1 is like this. The ripple that are present in this domain. Okay, and this is for a Let me use the eraser. Okay, so let me, this one is eraser, right? Yeah, no, let me do it again. Okay, see the refill that, sorry, I didn't check this. Okay, sorry. Okay, so I have to take the pencil here. Okay, no, so let me write, let me draw this, the refill that are present in this pass band, and it will come to the this is for a low pass filter. Okay, if people have studied this in theory class also, that the ripple that is present here is RP, sorry, I am denoting as RP, that is the pass band ripple. Okay, and for the Chebyshev type 2 IR filter, the response is like this. That for a low pass filter response, there are no ripple present in the pass band, but there are some ripple that is present over in the stop band. Okay, and this ripple I am denoting as a RS. Okay, so this is the some basic difference between the Chebyshev type 1 and Chebyshev type 2, and so the use of these two, Chebyshev type 1 and Chebyshev type 2, is based on your application. You can use Chebyshev type 1 and either Chebyshev type 1 or Chebyshev type 2. Okay, so you just go through the content in the theory class. You will get to know which kind of filter is used where, and the Chebyshev type filter where we are going to use. Okay, so if you are not able to get that from uh, still if you are not getting, then you can go use Google and you can search it also. Okay, so I'm not I already search and take that, means see that, it's your duty. Just if you are not able to uh, get that where to use Chebyshev type 1, where to use Chebyshev type 2, please go through the please search it and see the thing, right? So these are the uh, some basic difference between Chebyshev 1 and Chebyshev 2. So now first I'll list out the thing that we are actually going to discuss in this lab. Then we uh, proceed towards our program. Okay, so let me clear all. Let me list out the thing. Okay, designing of IIR Chebyshev filters. Chebyshev filter using Python. Okay, so what we are going to do here is, first one is I'm writing ch, okay, not writing all the, otherwise let me write Chebyshev type 1 and for low pass filter, high pass filter, then band pass filter, then band stop filter. Okay, then next one, Chebyshev type 2. Similar, so let me copy it from here. Okay, so we are going to design for the Chebyshev type 1 and Chebyshev type 2 for the uh, four type of filters. Okay, what I will do is, first I will do for Chebyshev type 1 low pass and a band pass filter. Similarly for Chebyshev type 2 also a low pass and a band pass filter, and it's your duty to do for the other one, high pass filter and the band stop filter for both Chebyshev type 1 and Chebyshev type 2 filter. Okay, so now let's start our first program, that is, so let me run it. Chebyshev type 1 filters. Okay, so let me make it as a heading. Then let me first take all the libraries that I have needed here. And in the previous lab I told you I used a different kind of uh, plotting procedure, right? The technique that I have used is uh, different from other technique. So that plotting technique here also I am going to use. It's up to you whether you are using this technique or the earlier taught techniques that I have do with other labs program. Okay, I taught about three type of plotting um, uh, procedure, right? You can use soft plot, you can use figure number 1 2 3 like that, but here I am using a different one to give you a some additional idea about the plotting of figure in Python. Okay, so it's up to you whether you are using this or other one. Okay, okay, so now let's write import, sorry, from numpy import log 10 comma pi, then from scipy dot signal import IIR filter freaks. Okay, then SOS freaks FREQZ. I forgot to mention one thing, that here also you can design two type of filter, both analog and digital type. Okay, so that's why I am taking the from scipy signal freaks and SOS freaks. Okay, and the function of these things in our previous lab we have seen, right? So that thing I am not going to repeat it again here, because the functions are pretty similar. Only we have to change, in place of butter we have to give Chebyshev 1 or Chebyshev 2. Okay, so next is Chebby 1 comma Chebby 2, right? Then import matplot library.pyplot as plt, import matplot live.pyplot as plt. From pylab import clf figure for the plotting. Okay, we have seen this, so I am not explaining every term here again. Okay, figure. Okay, so this is sufficient, I think. So now let's go to our code section, next cell. Okay, so we have some error, cannot import name IIR filter from scipy dot. Let's see why. Sorry, FILTER. Okay, now it is work. Okay, now let's see for our first program, that is Chebyshev type 1 low pass filter. Okay, so now let's see. Chebyshev type 1 low pass filter, IIR Chebyshev type 1 low pass filter. Okay, so first now let's do for the analog IIR filter designing. Okay, uh, in the previous lab also we have did like this, the sequence is like that. So we first let's do for the analog type filter, right? So analog So let me do one thing. Let me see what I have actually kept the comment. Okay, so it will be better. Let me see it once again. The analog IIR LPF. Okay, no problem. For analog IIR 1 LPF. Okay, so we already imported the requisite library. So now let's start writing the code. Okay, so here I didn't mention the criteria, so let me first mention the criteria. What is my design criteria? And it's pretty similar. Okay, so I'm not going to do it again, so you can take it. Design criteria: order 3, cutoff frequency is 1 kilohertz. Okay, and the sampling frequency is 2000 hertz. I will take. Okay, and for band pass and band stop filter, this is the thing. So cutoff frequency is 1 kilohertz. Okay, no problem. We have did with this also we only, right? So let me check it. 1 kilohertz. Yeah. Okay, so let me copy this design criteria. I forgot to mention at that time. So okay, so for band pass filter, sampling frequency is this is okay. Okay, here one other parameter we have to give, that is for Chebyshev type 1, the passband ripple, and the for Chebyshev type 2, the stop band ripple. Okay, so I am going to take the pass band ripple, that is RP, small RP, okay, is equal to pass band ripple is so. Before going into the code, as I told you earlier, so this about RP and RS in the introduction itself I have told about this. So let me show you the Chebyshev 1 and Chebyshev 2 that we are actually imported from the scipy dot signal, such that you will get a clear idea what is that actually. So first one is the Chebyshev 1. Here you can see what is the use of this Chebyshev type 1 digital and analog filter designing. Okay, these are the parameters that are this command take. Okay, design an order digital filter or analog Chebyshev type 1 filter and return the filter coefficient. Okay, so this is the order of the filter, and first one, right, the RP is the maximum ripple allowed below unity gain in the passband specified in decibel. Okay, as a positive number. This is the only reason I want to show you. Okay, so what is I'm giving here, that passband is my 5 dB. So I'm not mentioning the unit here, but you can refer it here that the value that you are giving there, it is taking as a decibel. Okay, so for that reason I'm not giving any uh, unit over there.
Similar to that, here also you can check, that is RS, means what? The minimum attenuation required in the stop band. Here also specified in decibel is a positive number. This is the attenuation and this is my maximum ripple. Okay, so RP and RS is equal to, for both take 5. Okay, so okay, it's to you for 5, or let me take the maximum ripple that is provide allowed in passband is as 10. Okay, or the, and this is the maximum ripple that is passed, allowed in the stop band. That is the second one, RS, is going to be used in my Chebyshev 2 type, and for the RP, that is the maximum ripple that is allowed in the passband, is going to be used in Chebyshev type 1. Okay, so I think it is clear. So now let's start writing the code. B comma A is equal to Cheby1 so Cheby1. Then if you see, then we have to provide the order of the filter, then RP, then omega n, which is a, we already discussed, it's similar to that of the Butterworth filter. Then B type is which kind of filter you want to design, then whether it is analog type, or if it is analog then it is true, if it is digital then analog is equal to false, right? Output is BA, or what is your output, we already discussed about, there are 3 kind of output we can generate from it, so it's up to you. Okay, so now let's give, so I'm taking the order is 3 because I already mentioned. Okay, then the RP is 10, I'm taking here. Okay, already uh, I already mentioned it earlier. Okay, so then the cutoff frequency we have to put, what is the cutoff frequency there, 1 kilohertz means 1000, right? Then the B type is low pass, right? Then analog, we need analog 1, so analog is equal to true, right? Okay, then okay, what it will do, let me comment it, generate Chebyshev type 1 filter, right? Then w comma h is equal to fix. You know why we using fix here? So b comma a with, let it to be 10,000, okay. So 1024 also you can take, no problem in that. Okay, to calculate its frequency, response of the filter. Okay, then we convert this to dV is equal to 20 log 10 okay. After that we are going to plotting the graph. Okay, this is for the analog type. So now let's plot the graph. Plotting. Okay, I forgot to make a comment here. Plotting, that is fig 1 is equal to figure in bracket 1, right? Then fc is equal to fig 1 dot subplot, sorry, add subplot. Okay, then dot semilog w comma h of dv, right? Yes, then g dot set title as frequency response of Chebyshev type 1 IIR, sorry, analog low pass filter LPF, right? Low pass filter, okay. Then fc dot set x level frequency in hertz. Sorry, I'm not putting it. Okay, so it's not coming. Why? Okay, so we done this. Then fg dot set y level, right? Amplitude in dB. Okay, then plot dot line at, sorry, 1000 hertz and color red. Okay, fg dot grid with both and axis also both. Not axis, it's axis. Okay, then plt dot so. Okay, so it is all over for a analog type Chebyshev type 1 filter. Now let's see for digital type filter. Okay,
Yeah, I forgot to mention about that cutoff frequency because we changed it to 500, right? So let me make the changes here from the beginning. It will be better. Okay, cutoff frequency as 0.5 kilohertz. Okay. Okay, so for Chebyshev 2, let's do this. Okay, what the changes that we have to make here is like we have to put JB2. Okay, I already imported the JB2 also. You can see it in the library cell where I imported all the library. Where is the pointer? Sometimes it is not. Yeah, you can see JB2 also I imported, so I can use that, right? So it is for IIR JB2 LPF. Okay, where is the point? A little bit. 1 second. Okay, the pointer is not. That is a Chebyshev 2 low pass filter. The first one Chebyshev 2 filter. Okay, then we have to make the change here. That is 2. Okay, then first one is my order of the filter. Second one is the stop band attenuation. Okay, this is the maximum allowable stop band attenuation, right? So, or you may call it stop band ripple, maximum stop band ripple also, no problem in that. So it is a then the cutoff frequency I'm taking as 500, then the B type as a low pass because I'm using low pass, then analog is equal to true because it's the first I am designing a analog filter, right? Then the frequency response, there is no change in that. Then I just convert it to dB. Then the plotting part. Okay. Here Chebyshev 2. Okay, then here I have to make Chebyshev 2, then no other type changes is needed here, then go to the plotting. Okay, in plotting here I have to make it to 2. Okay, and then I think no other changes is needed. Now let's run it. Yeah, its ripple is little bit very high because I'm taking 10, right? So one thing I can do, let me change the past stop band ripple to suppose 2. Okay, and here also 2, right? Yeah, no, it's not changed. Yes, I have to make something, made something wrong or what? As we see, by decreasing uh, the stop band ripple, we are not getting a good graph over there, right? So what I'll do, let me change, uh, let me increase it. Okay, from 10 let me increase it so that we'll got a good graph there. Okay, it's up to you how much maximum ripple that you may allowed there. Okay, for the clear visualization only I am taking a higher value. Okay, so let me take 40. Okay, then here also 40. Let's run it. Yeah, you can see now it is a little bit good. Okay, if you are confusing, then take 10 also. There is no such issue. It's all user input parameters, right? You are going to give this, so it's up to you. It's based on your design parameter. You can change this, but for a good visualization I just changed it. You can now see it is little bit very clear, right? You can check it from here also. My cutoff is at 500, right? 100, 200, 300, 400. Here it is 500, right? Then the attenuation limit, or you may say the stop band ripple is present over there, right? So okay, so this is all about. If you increase more, it will be a good um, graph then. Okay, so I'm not doing that. It's up to you. Okay, so now let's go to our next uh, program, where we can write a Python code for uh, first. Let's write a Python code for the Chebyshev type 1 filter, Chebyshev type 1 IIR band pass filter. Okay, in the starting only I have told that I will do from both type 1 and type 2 only low pass and band pass. Okay, and the other two, high pass and band stop filter, you have to do that, right? It will give you a, because in every program I have did all the thing. Okay, so it is in the content, means rest of the lab are on application oriented. If we see in the in view of the course syllabus, the theoretical thing that we have studied in theory classes, that it is the last one, right? The IR filter designing uh, in in different kind of uh, in different methods we are using here, and the bilinear transformation method, right? In theory classes we have studied four type of method. I already listed out there. Okay, so for that I am not doing that for program. It's your duty, you just do that. Still, if you have any doubt, I will figure it out. Okay, so now let's do for the Chebyshev type 1. Type 1 band pass filter. Okay, okay, then okay, so let me make the comment first. IIR
Chebyshev 1 bandpass filter. Okay, for analog okay, then B is equal to Chebyshev 1. Okay, so here the parameters are, first one is the order of the filter, I'm taking 3. Okay, the next one is the maximum allowable pass band ripple, right, RP, I'm taking 5. Okay, next one, see the cutoff frequency. As it is a band pass filter, we have to supply here a band of frequency. Okay, so for that what we have to do is I have taken 100 and 10,000, sorry, 1000 as my FC1 and FC2. Okay, then next parameter is B type, which is equal to B type, which is equal to band pass, right? Then the next thing, that is analog, which is equal to 2, right? Then yeah, this much. Now let's comment this to generate Chebyshev 1 bandpass filter coefficient. Okay, then this is equal to Fricks B comma A comma 1000. Okay, what it will do is that it will generate to find out the frequency response. Okay, Okay, then we have to convert this into dB, right? So for that, this is equal to 20 log 10 absolute value of h, right? Okay, this is for the analog. Okay, now let's plot this. Plotting, right? So fig 1 is equal to figure 1, then is equal to fig 1 dot add subplot okay, then fg dot semilog x plot with respect to w comma h dB, right? After that, we have to add the title here, set title as sorry, frequency response for Chebyshev type 1 bandpass filter, right? Yes, then put fg dot set x level as x level is frequency in hertz hertz, sorry, put this in bracket, Okay, then g dot set y level as amplitude in bracket in dB. Okay, then plt dot axv line first put in the that line in the lower band, that is my 10, oh no, sorry, 100, right? Yeah, 100 color is equal to red, right? Then dot line 1000 comma color is equal to red, right? Then fg dot grid which is equal to both and axis is equal to both. Okay, then g not g plot dot so okay, so this is for the digital filter. Okay, sorry, this is for the analog filter. So now let's do for the digital one. For digital bandpass filter, here SOS which is equal to JB1 3 comma no 5 comma bracket to give the cutoff frequency. Okay, then the next parameter is b type. This is equal to bandpass. Okay, then the next parameter, that is analog. This is equal to false here, right? Then the next parameter is fs. We have to give fs as it is a digital filter, right? So I'm taking fs as, if I take fs as 2000, then it will show an error, so it's better to take 4000. Okay, or we can do one thing, take 2000 only, or here we can take this as 500, otherwise 500 it is very less. The graphical view is not good for that. Okay, so what I'll do, let me take it as 900 then, and this also 900. Let's see. Okay, then the next code is that it is equal to SOS thousand HDB, which is equal to 20 log 10 is of H. Okay, now let's do the plotting for this. Plotting. So here, let's start the plotting. Figure 1, which is equal to figure 1
Then clear the figure. Then if G is equal to G1 dot add subplot then plot it plt dot plot w divided by pi hdp, right? Then fg dot it's not that one, fg dot plot, okay, fg dot set title as frequency for here must be for analog, here frequency response of of digital Chebyshev type 1 bandpass filter. Okay, this is all about the title. Then now add the X level to this. Normalized frequency. Amplitude amplitude in dB. Okay, then put fg dot grid which both then axis is equal to so both, right? Okay, so let me little bit fast. Okay, then plt dot so okay, it is over. Now let's run this. Here something error is coming. Okay, here it is axis, not I put it wrongly, double is here. Okay, let's run it now. Still SOS array must be in P shape n.section C. Yeah, we are getting this error, so let me okay, so we forgot one thing here to mention output. Okay, output is equal to SOS, right? Then put a comma here. Now it is right. Okay, so now let's run it. You can see the output curve. Okay, so this is for the digital one, and the first one is for the analog type filter. So at 100 and at the it is not actually uh, recognized here, so you can put a limit on the axis and try to get the thing right. Okay, so this is for the bandpass filter with Chebyshev type 1. Okay, we can do a thing that will be better. Okay, so let me change the thing and then we can see make it to 3000. Okay, now let's run it.
Okay, so here it is the refill that are we are getting in the passband. Okay, so we are giving the amplitude as 5 dB, so it is little very small here. That's why it is not means recognized as that of the previous one, right? So it is very less here. Okay, so I think it is clear to all of you. Now let's go for the graph that are shown here. It's starting from 10 to the power minus 2, right? Means if you see the Bode plot, it is starting from 10 to the power minus 2, means 0.01, right? If we limit the axis, then then also graph will not show any that graph is not good, right? So it's better to keep it like this only. So do one thing, take this image and take and give in the record, right? So don't put the limit on x-axis, it will hamper the result. Okay, so now let's do for the Chebyshev type 2 bandpass filter. So for that, let me make a heading here. Bandpass filter. Then let me paste it here and make the required changes that I need. Chebyshev 2. Okay, then Chebyshev 2. Chebyshev 2, right? Then the changes we don't need actually, right? Make the change here. Then here Chebyshev 2 again. I think it is okay. Now we can run it. Now let's run it to see. No. Okay, because we have the stop and ripple we have to increase here. We already seen, right? So better to take this as 50. It will give a good result. Maybe let's see. Then here also 50. Now let's run it. Okay, so this is my pass band, this is my stop band. Okay, So this is for the analog type and this is for the digital type. Okay, so with this we finished our filter designing part, and other four filter, as I told you earlier, you have to do by your own. If anybody find any difficulties, let me know. I will try to solve it. Okay, it's pretty similar. All of you now familiar with Python, so I hope that you people do that thing, because the only one thing that I have left is that four type of filter. Otherwise I have did all the thing one by one, writing the code, and make you try to make you understand the command, the attributes of different libraries, to uh, to plot different kind of figure, or you may say different kind of plot with different methods, right? And try to give my 10% to make you understand all the thing. Okay, so I hope you people enjoy this uh, filter designing part, and learn something from this. Okay, so with this we conclude today. Okay, thank you.